Hello everyone, I am Fatimatul Hibayam and today I am presenting my seminar on Servlet Chaining. Servlet Chaining is an important concept in Java web development where multiple servlets work together to process one client request step by step. In this presentation, I will explain the concept, working process, implementation, examples, advantage and comparison with filters. Here the three pictures showing servlet chaining conceptual principle. This is a modular workflow where the output of one servlet become the input of next. Process here, a client send an initial request, server A processes it and pipes partial response to the servlet B. That is a transformer which then sends the final formatted data back to the client. And second one is filter chain API, that is modern implementation. This is a standard way to handle cross-cutting concerns like security or logging before a request reaches its destination. The process here, a request passes through a series of filters, example authentication or logging or compression. Each filters can inspect or modify the request or response using the do filter method before passing it to the target servlet. And the third one is request dispatcher mechanisms. This shows how one servlet can delegate tasks to another resource on the server. Here two things. Forward transfer control. Servlet A passes the entire request to servlet B. The client is unaware of the switch and receives the final response directly from servlet B. And next is include combined responses. Servlet A processes part of the request, includes the output from the servlet B like a header or footer, and then finishes the response itself. Servlet chaining is a technique in Java where multiple servlets process a single request in a defined sequence. Instead of one servlet doing all the work, different servlets handle different tasks one after another. Each servlet performs a specific responsibility such as a validation, authentication, formatting or business logic. The output of one servlet becomes the input of the next servlet in the chain. Finally, the last servlet sends the complete response back to the browser. This approach makes applications modular, reusable and easy to maintain. The previous we studied that what is the servlet. Here why use servlet chaining? There are many reasons to use servlet chaining. First, it divides complex tasks into smaller manageable units. Second, it promotes code reusability because one servlet can be used in multiple applications. Third, it supports data validation at different levels. Fourth, it allows content filtering and modification. Fifth, it helps logging and debugging. Finally, it provides a modular design that is easier to maintain and upgrade. Now, let us understand how servlet chaining works step by step. First, the client sends a request using a browser or application. Second, the server receives the request and sends it to the first servlet. Third, the first servlet performs its task and processes the data. Then the request and response object and response object are forwarded to the next servlet. The next servlet continues processing. Finally, the last servlet generates the final response and sends it back to the client. This creates a smooth sequence of processing stages. This diagram explains the architecture of servlet chaining. The process starts with the client request. The request first goes to the servlet 1, which performs the first stage of processing. Then it is passed to servlet 2 for additional processing. After all processing is completed, the final response is returned to the client. This architecture is similar to an assembly line where each stage performs one task. It improves organization and scalability. This slide shows how servlet chaining is implemented using request dispatcher. The method getRequestDispatcher is used to identify the next servlet. The forward method transfers control along with the same request and response objects. Example, request dispatcher rd equal to request.getRequestDispatcher of second servlet, rd.forward request response. Another method is include, which includes output from another resource without full forwarding. These methods are commonly used in Java web applications. This slide shows the code of the DB-Link servlet, a classic example of servlet chaining. In older HTML, the blink tag was used to make text blink. This servlet removes those blinking tags from the content. The servlet reads input data line by line using a buffered reader. Then it replaces blink and closing tag of blink with empty strings. After processing, it writes the clean output using print writer. This example demonstrates content filtering where a servlet modifies data before sending the response. Now let us see the DB-Link servlet in simple steps. First, it receives HTML content. Second, it searches for blinking tags. Third, it removes unwanted formatting. Finally, it sends clean HTML output to the browser or next servlet. This is a simple but effective example of how servlet chaining works in practice. A common real-world example is an online shopping system. When a user places an order, several steps happen in sequence. First, a servlet checks login and user session. Second, another servlet processes selected products and cart items. Third, another servlet handles payment securely. Finally, one more servlet generates the order confirmation. Each servlet performs one task, making the application efficient and organized. Now, let us discuss the advantages and disadvantages. Advantages: better code structure, reusable components, easy maintenance, scalable design, flexible processing. Disadvantages are slight performance overhead, more configuration required, debugging long chains can be difficult, error handling becomes more complex. So, servlet chaining is powerful but should be designed carefully. Servlet chaining and filters are related concepts, but they are different. In servlet chaining, multiple servlets process the request one after another. It is mainly used for complex workflows and business logic. Filters are special components used for pre-processing and post-processing tasks. They are commonly used for authentication, logging, validation, and compression. Servlet chaining is more flexible while filters are simpler and common tasks. The key takeaways are servlet chaining uses multiple servlets for one request. It improves modularity. It makes the code reusable, easier to maintain, useful in Java web applications. Thank you everyone for listening to my seminar on servlet chaining. I hope this presentation helped you understand how multiple servlets can work together efficiently in Java web development. I am happy to answer any questions in the comment section.